Today I will talk about evolution of software system. The term evolution was used by Mark I. Hartman in 1965 to define the dynamic growth of software. It attracted more attention after May Lehman proposed eight broad principles about how certain type of software system evolve. Bernard and Rajli researched the term software evolution, but found no widely acceptable definition of the term. Some research and practitioners use the term software evolution as a substitute for the term software maintenance. Lowell J. Arthur distinguished the two terms as follows. Maintenance means preserve software from decline or failure. Evolution means a continuous changing software from a worse state to a better state. Software evolution is like a computer program with input, process, and output. K. Burnett and J. Zhu use maintenance for all post-developer support, whether they use evolution for refer to perfect modification, modifications triggered by any change in requirement. Software evolution is studied with two broad complementary approach. Explanatory. This approach attempts to explain the cause of software evolution, the process used, and the effects of software evolution. The explanatory approach study evolution from a scientific viewpoint. Process improvement. This approach attempts to manage the effect of software evolution by developing better methods and tools, namely design, maintenance, refactor, and re-engine. The process improvement approach study evolution from a engineering viewpoint. Next, I will talk about SPE taxonomy. The abbreviation SPE refers to S specific, P problem, and E evolving program. In 1918, May Lehman proposed an SPE classification scheme to explain the way in which programs vary in their evolutionary characteristics. Lehman observed a key difference between software developed to meet a fixed set of requirements and software developed to solve a real-world problem which change with time. The observation leads to the identification of types S specific, P problem, and E evolving programs. S type specific have the following characteristics. All the non-functional and functional program properties that are important to its stakeholder are formally and completely defined. Correctness of the program and respect to its formal specification is the only criteria of the acceptability of the solution to its stakeholder. The example of S-type calculate of the lowest common multiplier of two digits. P-type problem. Based on the practical abstraction of the problem instead of relying on a completely defined specification. The P-type program resulting from the change cannot be considered a new solution to a new problem. Rather, it is a modification of the old solution to better fit the existing problem. The example for P-type, the program that plays chess. E-type, evolving, one that is embedded in the real world and it changes as the world does, have the following characteristics. The first characteristic of the E-type program is that the output of executing the program is not definitely predictable. The second characteristic is that program executing change its operational domain and the evolutionary process is viewed as the feedback system. Next, we go to the diagram. For S-type, only real-world change, the others still static. For P-type, the real world might change, hence problem change. For E-type, program one that is embedded in the world, and it changes as the world changes.
Today I'm going to present about the laws of software evolution and their empirical studies. There are total 8 laws of software evolution. So for the first one is the continuing changing. The second one is the increasing complexity. And the third one is self-regulation. The fourth one is the conservation of organizational stability. The fifth one is conservation of familiarity. The sixth one is continuing growth, which is similar to the first one. So to distinguish between these two is the first law is about the facts that E-type software operational domain undergoes continuous change, while the sixth law states that not only software undergoes change, but also that some of those changes will be performed to increase the functionality of the program. Next, the seventh law, the declining quality, and the eighth law, feedback system. The seventh law related to the growth in entropy, which are associated with software product aging and or code decay. There are two types of aging, which are the software execution and the software product aging. The codicil are reflected by the three key responses, which are the cost of change, the calendar or clock time to make changes, and the quality of change software. Next is the empirical studies. The FISH project is the main source of the empirical studies. Damon and his colleague studied the evolution of release from 4 CSS systems. The study shows that during maintenance process, a system tracks a growth curve that can be approximated either as linear or inverse square, which are represent the growth phenomena as an inverse square of the continuing effort. Those trends validate the laws which only include the first law, second law, third law, the fifth and sixth, also the eighth law. While the fourth law is neither supported based on the metric presented and the seventh law based on theoretical analysis. That's all from me. I will pass it to the next presenter. Thank you.
And now I am going to discuss about my part, practical implication of the law. Lemon proposed more than 50 rules based on the 8 laws of software evaluation, and these 50 rules are categorized into 3 parts: assumption management, evaluation management, release management, and this 3 is relevant with the practical application of the law. And now, evaluation of force system. The force movement is attributed to Richard M. Stallman. For the first time, he is the guy start to think about to make a free operating system for the user. That's the reason we make an organization also. Then what does mean by force? The force actually short form of free and open source software. The FOSS is a class of software that is both free software and open source. That means we can get a source code very easily and we can modify or develop the source code in our own way, and also and there we don't need to pay anything for the source code. The two significant contributions to the evolution of free and open source software, first is GNU project and the second is Open Source Initiative. And now GNU project. In 1983, Richard Stallman, a former programmer of MIT AI Lab, he launched the GNU project to write a complete operating system. In 1989, GNU project got the license, and 1992, GNU project became successful when the Linux was released as a free software, and it was very available in the internet in 1990 that greatly contributed to the propagation of FOSS. And now the Open Source Initiative (OSI). It is also another non-profitable corporation with a global scope, and it was founded by Bruce Parnas and Eric S. Raymond in 1998. It actually advocates for the benefits of open source and to build a bridge among different constituencies in the open source community. And this organization is promoted by the Netscape Communication Corporation. And now the onion model of force structure. In the middle, we see the core members. They are also responsible to make a force-based software, and they also have another team that we call contributing developer. They actually add and maintain the freezer. And after that, we see the active user. Active user means they take ownership of system testing and defect reporting. After that, we see the passive user. They are actually not responsible, or they are not buying the system. They just use the system as a free. That's all for me.
Maintenance of COTS-based system off the shelf is unit of composition with contractually specified interface and explicit text dependencies only. A software component can be developed independently and is subject to composition by third parties. And why it is being used often in software development. This is because it's high quality. The component is well tested. Next is because we can gain in productivity. Use commercial component. Use of human resources. Prevent system development. They have no visibility of the details of the component or the code they need for integrating the system is written and modified by integrators. Code is for delivering and wrapping individual components and the glue code for the component. And wrapper is code built to usher underlying component from other components. And glue is component that with the function of combining different components. And tailoring is the enhanced functionality of a component. Why maintenance of CBS is difficult? It is frozen functionality. It might be freezes using. And next is compatibility of upgrades. It is incompatible of upgrading and then Trojan horses because it is something that malicious that we don't want that might have in CBS. And then the unreliable COTS components. The COTS component might be unreliable and the middleware might be defective.
Good evening everybody, I'm Arshana and I'm going to present maintenance activities for CBS. There are few maintenance activities and I'm going to explain each one of them in a simplest form. Okay, the first one is identification and tracing. Basically it involves identification of requirements of modification or maintenance. The second one is analysis. In analysis, the modification is analyzed for its impact on the system, including safety and security implications, and also the cost of modification is analyzed and estimation is concluded in this phase. And then the next one is design. In design, new modules which need to be replaced or modified are designed, and then those new modules are coded and expected to do unit testing in parallel in implementation phase. And then the next one is system testing. In system testing, by following regressive testing procedures, integration testing is carried out between new modules and the system. And the next one is acceptance testing. After testing the system internally, it is tested for acceptance with the help of users. Okay, and then after acceptance test, the final test is takes place at client end after the software is delivered. And then the last one is maintenance management. Configuration management is an essential part of system maintenance. Okay, it is aid with version control tools to control versions, semi-versions or patch management. Okay, let's move on to the next slide. Design properties of component based systems. Choice of the components, architecture and design used to perform integration on the components are the main influencing CBS maintainability. Okay. When it comes to component selection, there are few attributes of components which affect the evolution maintenance of CBS. Okay. On the other hand, based on the study, we identified few design attributes of a maintainable CBS, which is encapsulated component collaborations, minimal component coupling, consistent failure handling, high level of visibility, controlled component interfaces and dependencies, and so on. That's all from me. Thank you.